Okay, the national grid. What the national grid is a series of overhead cables and transformers. It does not include power stations and it doesn't include homes. It covers the entire country and it also links to other countries as well. So we link it to France and to Ireland as well. But make sure you just know it's the overhead cables and transformers. Right, we're going to meet some formulas in a second to try to explain as to how the national grid works and how it saves energy. P is power in watts, V is voltage in volts, I is the international symbol for current in amps, and R is the resistance in ohms. The formulas that we use are P equals VI, so the power is voltage times current. And we also use Ohm's law. We'll meet this later on. Ohm's law is basically voltage equals current times resistance. And so if you notice, what we can do is we can actually replace the V in the formula above where it says P equals VI. And instead of saying V, we can actually say V equals IR. So before you know it, we put it into the formula so we get that there. All I've done is replace the V with IR. Look at that carefully, hopefully it'll make sense. And that can be simplified as P equals I squared R. So essentially, what that is telling us is the power of any device is the current squared. Okay, now this is important because what it's saying, if you've got a very big current, you're going to get a massive amount of power being lost. So for example, if we transmitted electricity with a really high current, using that formula P equals I squared R, you get the power is 500 amps squared times the resistance 100, which gives you 250,000 watts. Now, if I can actually lower the current, if I can make the current lower, say 5 amps, you can see that this time P equals I squared R is P equals 5 squared times 100, which gives you 2,500 watts. Obviously, a lot less than 250,000. And so what we try to do in the national grid, and what we do is we try to lower the current when we send electricity a long way. When you lower the current, you have to increase the voltage. So, starting at A, there's a step-up transformer. What that does is it takes the voltage at the power station of 25,000 volts and it increases the voltage to 400,000 volts, and that has the effect of lowering the current. So you end up with a low current going along the wire, and so therefore the wire there doesn't lose a lot of energy in the form of heat. When it reaches a town, for example, then you need to lower the voltage because 400,000 volts is too big a voltage for homes and for industry. And step-down transformers change the 400,000 volts down to 240 volts. And at this point, you've got a high current. And you can see that the factories might need 11,000 volts rather than 240 volts. So this system means that we do not lose energy in the form of heat. That's really important. You remember that. You lose energy in the form of heat in the wires. By having a high voltage, you don't lose the energy. Right, so high voltage grid reduces the energy losses in the form of heat, and it does it by lowering the current. And that there is the national grid.